Well, Happy New Year, and we're entering a new 2025. Before we really get into the business of 2025, we should let's remember a few things that happened at the end of 2024. And at the end of 2024, we actually lost several Nobel laureates. Most people have probably heard of the passing of Jimmy Carter already, former President Jimmy Carter, on December 29th, 2024. But two other Nobel laureates, specifically two other Nobel laureates in chemistry, also passed away at about that same time, basically on the same weekend, really. December 28th, 2024, that Saturday, Martin Karplus passed away at the age of 94 at his home in Boston, Massachusetts, after a fall. And then, of course, Jimmy Carter passed away the next day at the age of 100. And we also lost J. Fraser Stoddart on December 30th, 2024, at the age of 82. He was an organic chemist and the 2016 recipient of the Nobel Prize in Chemistry for his work in nanomaterials and molecular machines, notably. So it's been a somber week for the Nobel Academy, and we've lost some major players in world politics and sciences, and we're certainly going to miss their contributions, although, you know, at their age, they've accomplished a lot, right? So, of course, Jimmy Carter, the former president, of course, he was president from 1977 until 1980, had only just one term. However, his humanitarian efforts and his past presidency were particularly notable, and he accomplished a lot in terms of free and fair elections. He accomplished a lot in terms of even eradicating several diseases. Most notably, he worked very closely to eradicate guinea worm disease. And, guinea worm infections, this is caused by a parasitic worm whose larvae may contaminate water. So it's very common in third world countries. And so when people consume this tainted water, the larvae mature inside the body. They may grow up to as much as 3 feet long. And then these worms burrow out of people's bodies, and they can cause blisters on the skin as they exit. It's fairly painful. And the eradication really began about 5 years after Carter's presidency ended in 1986. And that was when 3.5 million cases were recorded globally. And so Carter's work with the World Health Assembly and the Carter Center, most notably, they worked very closely to work with a lot of third world countries to pretty much eradicate this disease. And now there's really only a handful of cases, maybe fewer than 20 per year as of today. So it's virtually been eradicated. Also, Jimmy Carter was the only president to have graduated from the U.S. Naval Academy. And he had some engineering training, although the U.S. Naval Academy at the time did not specify a major. So he did have training as an engineer, and after graduation, he went into the service as an officer and served in nuclear submarines. He was actually a nuclear submariner, and through that experience, one of the more notable things he did was in 1952, at the Chalk River nuclear site in Canada, he was actually very instrumental in preventing a major meltdown. And so that was a big thing that he did. He was actually lowered into the reactor chamber, into the reactor itself, along with others, limiting to about, a very short duration because it was obviously out of radiation. And basically his job was to adjust the screws on the reactor in an effort to dismantle the reactor and prevent the meltdowns. So he was basically a hero. through that. And so his contributions are certainly very broad over the course of his long career. And so that's a pretty major thing. So rest in peace, Jimmy Carter. He's certainly earned it, right? Now, on December 30th, 2024, we lost Sir James Fraser Stoddart. And so he was a Scottish and an American chemist, mainly an organic chemist. And so he served as chair professor of chemistry at the University of Hong Kong. And he was also a Board of Trustees professor of chemistry and head of the Stoddart Mechanostereochemistry Group in the Department of Chemistry at Northwestern University in Chicago. And so his branch of field was supramolecular chemistry and nanotechnology, two things that he really pioneered, developing a lot of the chemistry for that. So he developed synthesis for mechanically interlocked molecular architectures for such structures as bromion rings, catenanes, retoxanes, that sort of thing. And he also worked on the molecular self-assembly processes, and this led to a lot of work in molecular recognition and molecular self-assembly. And so he received the Nobel Prize in 2016 for his efforts in this area. So passing away at the age of 92, he certainly made major contributions in this area, right? So I think that's major. The first one that passed away, however, and although the last one to be announced publicly was probably Martin Karplus. And so Karplus actually is probably more influential in my field in molecular biophysics and computational chemistry. He's the recipient, along with Michael Levitt and Ari Warshel, the 2013 Nobel Prize in Chemistry. And so this was awarded for the development of multi-scale models for complex chemical systems. And so Martin Karplus is an Austrian-American chemist. His family left Austria during the 1930s as a result of the Nazi occupation of Austria. And so they were fleeing Nazi Germany at the time. His family actually had kind of a history in science, and his father, or actually his grandfather, Johann Paul Karplus, was actually a professor of psychiatry at the University of Vienna. And one of his notable accomplishments was in the discovery. He played a role, maybe not discovered it single-handedly, but he played a role in the discovery of the hypothalamus, which is a small gland in the brainstem that has a major influence on the central nervous system. So even going back in his family lineage, Karplus was certainly destined for some sort of scientific accomplishment. And so he came to the United States, where he studied science, he studied biology, chemistry. He received his undergraduate degree at Harvard University and went on to study at Caltech, the California Institute of Technology. His doctoral research advisor was Linus Pauling, who was also a Nobel laureate, and not just a single Nobel laureate. Linus Pauling received 2 Nobel Prizes. He received the Nobel Prize in Chemistry in 1954, and he received the Nobel Peace Prize in 1962. And so Linus Pauling made a very wide array of accomplishments in the field of chemistry, and he was a major player in the field and throughout chemistry. So he was a huge influence. So Karplus graduated in 1954 with his doctoral degree in Pauling's lab. His thesis was entitled A Quantum Mechanical Discussion of the Bifluoride Ion. And so then after that, he went on to the University of Illinois at Urbana-Champaign from 1955 to 1960. And then he was at Columbia University for 5 years from 60 to 65. And he joined the chemistry faculty at Harvard University in 1966, where he remained until this past year. His major developments were in the field of quantum mechanical and molecular mechanics, which he received the Nobel Prize. One of the major software that he developed was a software called CHARM, which is spelled with 2 M's. And so that's really kind of an acronym for Chemistry at Harvard Molecular Mechanics. And so there's a set of software for simulating biomolecules and proteins, nucleic acids, and there's also a force field which has been developed as well. And so he was instrumental in developing that force field. So Karplus played a major role. He also was very instrumental in the development. He's got an equation named after him. That's the Karplus equation. And so this equation describes the correlation of the J3 coupling constants that are in nuclear magnetic resonance spectroscopy. So there's correlation between those coupling constants and dihedral torsion angles. And so you can actually graph this out, and you can see that relationship graphically. And so this equation was named after him for developing that equation, right? He had, Karplus had a very broad list of influence, and he had a lot of students and postdocs that trained in his laboratory. Some of these people include Charles Brooks of the University of Michigan, Ann Arbor, Axel Brunger at Stanford University, J. Andrew McCammon, who is at the time was in Texas, but now he's at the University of California at San Diego. I actually met Andrew McCammon in the past. He came to give a lecture when I was at the University of Pittsburgh, and but then later on, so Andrew McCammon worked with Karplus on the first ever molecular dynamics simulation back in the 60s of a protein. At the time, molecular dynamics was just being invented, and so molecular dynamics essentially takes a molecular mechanics force field, and it combines that with essentially Newton's laws of motion to produce a time-dependent simulation. And so McCammon and Karplus worked on a simulation of the bovine pancreatic trypsin inhibitor, BPTI. And so that was published, and that was their major accomplishment. McCammon also trained several other scientists. McCammon actually trained Scott Northrop, who passed away about in 1918. He was a professor of chemistry here at Tennessee Tech University. And he is actually the primary person that our molecular modeling laboratory is named after here at Tennessee Tech. Scott Northrop studied with Andrew McCammon, and together with Northrop and Stu Allison, they developed a theory for using Brownian dynamics simulations, and they combined these with analytical methods to calculate rate constants for diffusion-controlled enzymatic reactions. And then they used these realistic models for the enzymes and to describe their interaction with various substrate models. So that was his McCammon and Karplus's influence extended here to Tennessee Tech. And then Scott Northrop worked with Dr. Bowles, Jeffrey Bowles, who's our department chair right now, and that they actually developed a method for homology modeling, although they didn't call it homology modeling. That they used another term, I think it was mutational extensions, which was essentially homology modeling. The Bowles-Northrop terminology didn't really catch on. So now it's called homology modeling. Another scientist that trained here in Tennessee that worked closely with McCammon and hence had influence from Karplus is Yinglong Mao. And so Yinglong Mao, he actually worked with us at the Center of Molecular Biophysics at Oak Ridge National Lab, and then went on to do a postdoc with McCammon's laboratory. And he worked on accelerated molecular dynamics and essentially using quantum mechanical calculations, and they were able to calculate the free energy through those simulations there with Gaussian. So that was a major thing that he worked on, the accelerated MD, and they used Gaussian accelerated MD to calculate those free energy landscapes of proteins and other biomolecules. So that was pretty major there. Also, of course, mentioning Oak Ridge National Laboratory, Karplus also trained Jeremy Smith, who is the director of the Center for Molecular Biophysics, and Jeremy Smith trained Jerome Baudry, who I worked with at Oak Ridge National Laboratory. Jeremy Smith's group does a lot of simulations on cellulose and energy. They also do a lot of neutron scattering experiments at Oak Ridge National Laboratory and simulations of proteins and other biomolecules. And Jerome Baudry, he studied with Jeremy Smith and also studied under Klaus Schulten. Klaus Schulten is at the University of Illinois Urbana-Champaign. Well, was. He passed away a few years ago. And Klaus Schulten discovered, he invented the NAMD program for simulating proteins and biomolecules, as well as the VMD software that we use for visualizing molecular dynamic simulations. So Schulten also traces a lot of his influence to Karplus. And of course, Arie Werschel, he studied under Karplus, and he received the Nobel Prize in 2013 along with Karplus and Michael Levitt. So that was one of the major signature accomplishments. And Alex McCarroll at the University of Maryland, Baltimore, he worked very closely with the charm protein force field and developed that with Karplus. So obviously that had a major accomplishment there. You can really see where all of the different accomplishments of Martin Karplus came into play. And while he may have passed away last year, his influence lives on in several scientists today. Obviously, I can't mention every single one of them, but his influence is very broad, and I think his contributions to the world's a better place. Thanks not only to Martin Karplus, but also to Fraser Stoddart and, of course, former President Jimmy Carter. So we now mourn not just one Nobel laureate, but all three of them. Thank you.